Thank you. So welcome to Ambassador Show, a lesson in which it is always taking place from 2 to 4. But today we have started at 3 and we are going to take only 1 hour. So I take this chance to welcome you, join me. There are those who come to the lesson, then after a few minutes they leave. So today I want to challenge you. During the lesson, stay up to the end. The name of the topic is Particulate Nature of Matter. As you are joining, I always tell you, greet me in the chat section pale mahali pa kuandika message. Just say hi. I will respond. I will say hi to you. If possible, you can tell me where you're watching me from. Our lesson is going to take 1 hour, and today it's physics. Yesterday we were doing chemistry. And don't forget, in your calendar of events, just write that every afternoon you are supposed to be having a lesson with Sir Alex at the Ambassador Foundation lessons shows. I always take care of you guys because I must ensure that your parents have something to watch in my channel. You as students, there is something you're watching in my channel. So thank you and feel appreciated as we are learning about particulate nature of matter. Nasra Ismail, thank you for always being my follower. You have said hello and I'm saying hello to you. You're watching me when I'm at Limur. Where are you, Nasra? So allow me to talk about particulate nature of matter. This is a physics topic which is in Form 4 and it is a paper 1 topic. So what am I saying? Let's discuss it. It's a very short topic. It's not long like the way pressure is. It's a very short one. So when we say particulate nature of matter, first of all, I'm talking about the word particle, then matter. So normally, when I mention the word particle, particle signifies something very small. Particle. Ukikosana na mtu akwambia you particle. Amekudharau amekwambia nini? You are very small. So now, when we say particulate nature of matter, we mean matter exists in very small particles. The word small, to make it even look smaller, we say matter exists in very tiny particles. So that is particulate nature of matter. That's our topic, and I would like us to proceed and look at what is matter. That's the first time I would like us to talk about. What is matter? Let me pick a pen that is writing. So let's start by defining the term matter. Yes, this term was defined by, it was defined when you were at the primary. We are still defining it and we will continue defining it because it is necessary. So matter is anything that has space and, occupies space and has mass. Matter. That's the first thing. Ukishajua what is matter, now we can proceed and check what is a particulate nature of matter. Therefore, particulate nature of matter refers to the existence of matter in very tiny particles. So it means it doesn't matter how big a substance is, like a mountain, like this pen, like a piece of chalk, all those big materials, like a very big stone. All those big matter are made up of very tiny particles. That is the definition of particulate nature of matter. It doesn't matter how big an object looks like. That object can be splitted into very tiny particles. We've seen an ocean. All of us, we've seen an ocean. If you have not seen an ocean, you've seen a lake. You know a lake? Lake Victoria, Lake Nakuru, and Lake Mendaita, and the others. I don't know which lake have you ever seen. You can tell me which lake have you ever visited. But I always say, okay, let me talk of the ocean. The ocean that we know is the Indian Ocean, that we have gone there very many times. Lakini mtu akikuuliza kama umeenda hii Indian Ocean, mwambie ya. Hakuna muhuri ati wewe umeenda hii Indian Ocean. Hata mtu akikuuliza umewahi kupita ndege, mwambie yes. Umewahi fika Uganda? Umeenda South Africa? Nilikuwa huko last week. I mean, just don't be a boring friend. So now, all of us that we are watching this, we've been to Indian Ocean. You see the big mass of water that you cannot even see the other side. As big as it is, it can be split into very tiny particles. That is the point. Now, the other thing that I would like you to know again is this. Can you? Nishamwonyesha, wache niendelee na lesson eh? So, niendelee Miki. Ama ni unaweza ipose. Aya. So, so what we are saying is matter is not continuous, but it is made up of every or very tiny particles. That's why we talk about particulate nature of matter. At that point, we can see or demonstrate various, just proceed up to the end. So we are still there on the particulate nature of matter. So there are two ways in which always we can show that matter is made up of tiny particles. The one that we always use, I will use the one that is there in our book, whereby when you take a piece of paper, like this one is a whole piece of paper, like your book. You know how your book is? It's this way. So if you can cut that piece of paper into two equal halves, then you pick one of the half this way. You see, this one is smaller than this. Then again, the process continues. Cut this into a half, into another half, until you get a very small piece that even your hands cannot cut. So you can imagine now, the small piece of paper that you cannot even see there was once a big mass of paper like this. What does that mean? A paper is made up of tiny pieces of paper. So this applies to any other material. As big as it is, it can be made smaller. Or a big object is made up of very small particles, which when they are put together, it brings a big object. Particulate nature of matter. Now, another one, let me use another example that most schools nowadays are no longer using pieces of jokes. Wanatumianga marker pen kama hizi. But where I am, there is a room that we still use a piece of chalk, so you have to go with a piece of chalk, you write on it. So ukiandika hapo, you start with a very long piece of chalk. Lakini at the end, unajipata umebaki na a small piece of chalk. Kale ka small piece of chalk yenye mostly the teachers knows how to use it. Mwalimu ukiona amebaki na piece of chalk kadogo, ujue anytime that teacher will use that piece of chalk to wake a student who is sleeping. Mshoka, you are sleeping. Then mshoka anachapata amekongwa na piece of chalk kwa uso. So now, ukiangalia hapo chini ya blackboard, kuna border, a lot of border, which is actually making up the piece of chalk. If they are to be brought up together, they are the one making up the piece of chalk. So matter is made up of tiny particles. Another one is if we use a liquid substance. In this case, we can either use a copper 2 sulfate solution or potassium permanganate, whereby if you dilute in a container, say uko na container imekaa hivi, are we together? Then you dilute. What's the color of potassium permanganate? What's the color of potassium permanganate? Nasra, give us the color of potassium permanganate. As Nasra is typing, waje tuone kama atatype the correct thing. The color of potassium permanganate is purple. Purple. Is it purple or purple? Make sure the word, make sure the letter L comes out. Now, in the beginning, it is going to be very deep purple. That deep purple. Now, if you continue adding water, or you divide into two halves, then the other one you add water. This one it is going to be very purple. Okay, it's going to be purple, but the purple color is fading away. Yes, it's going to be purple, but it may fade away. Yes. Then lastly, hapa If you continue adding water, you will proceed with the process until it becomes colorless. The purple color fades away. It is another scenario, again, that shows that matter is made up of tiny particles. Can we proceed, Nasra? Nasra, you are the captain of this class, so you are supposed to be responding to every question I'm asking through the chat site. Nasra? I'm waiting for you. Can we proceed? Can we proceed? Can we proceed? Yes. Okay, so now we can proceed. So we are still in the particulate nature of matter. Now, let me ask a question, then we will proceed. Let me ask a question, then we will proceed. Let's say you have, I've not come here with a cup. Let's say you have cup like this. It is not a cup. Imejaa chai vizuri mpaka kwa the brim. We always say to the brim. Then chai imejaa vizuri. Na weke spoons mbili ya sukari ndani. Why is it that the tea will not spill out? Si imejaa vizuri mpaka kwa ikafumi even the meniscus. Look here. Let me explain that question so that you can tell me. Now, you have a cup ya chai. I don't know what I'm doing with that pen. I andiki. You have a cup iko hivi. Na umeweka chai mpaka imejaa hivi. Then unaweka spoons mbili ya sukari. But the tea will not spill out. It will not spill out. That's the question I'm asking. Why? Ungesema nini? Have said the tea will not spill out. What will you have said? Another scenario. Let me use this scenario. Angalia hapa. You have a flask. Imekaa hivi. Then salt ikawekwa hapo na ikwe imejaa vizuri, iko stoppered. And all this ni water. All this is water. Now, when this salt is made to dissolve, a space will be created here. A space will be created there. Explain why so. Kwanza hii, wewe, because you know your mom or dad hawapendangi sukari mingi. So, by the way, when you are, I'm not blaming you. Even when I was young, like Beverly, when I was your age, kwa napenda sukari. Lakini siku hizi sukari inanikasirishanga. Sitakangi sukari. But now, hiyo time ingine nikiwa form 2, nipate tu chance. Mama ametoka nje kidogo, nachukua ile mikebe ya sukari. Nachapa spoons kama 3, 1, 2, 3, 4, unaangalia yuko, unaongeza ingine na unaenda. The problem is what I will explain. The problem is this. The more you add sugar, the more they will not dissolve in a rich saturation. And when your mom will be washing the dishes, na vikombe anashanga, hii kikombe ya Nasra, hii kikombe ya Juliet, hii kikombe ya Beverly, mbona iko na sukari? Lakini nikisha kufunza hii topic sasa hautafanya hiyo planda. Ukiona umeweka sukari mingi mpaka imekataa kudissolve, usimalize chai. Ikifika mahali ambia niongezewe chai kidogo, hiyo sukari nyingine yote itadissolve. Now, I would like to know why that scenario is happening. I would like to know why it is happening. Nasra has given a answer. I'm still waiting for another person to give us a answer or his answer also. In the process, someone to comment on the video quality. How is the audio? Kijeshi1 following. Kijeshi1 is my colleague who is also teaching in YouTube. So if you can get time, baadaye, check on his YouTube channel. He's doing something great there. He teaches physics and chemistry too. So, Juliet is asking, can one try to do that? Yes. People are doing that outside here. Watu kunje ni wachokozi, they're doing it. So now, Nasra is a student, by the way, because particles of salt are able. That is what I was looking for now. That is exactly what I was looking for. Now, look here. When this salt dissolves, it does so by occupying the spaces within the water molecules. That's why the volume goes down. Let me explain it in this manner. The water particles or the liquid particles inakaanga hivi. Now, when in liquid particles, when you put some salt or sugar, it will dissolve by occupying the spaces here. This way. Then, at the end of the day, there is no increase in volume. Are we together? But if you keep on adding until all the spaces are occupied, now it forms what we call saturated solution. Saturated solution. A solution that cannot dissolve any more solute at a given temperature. Have I answered your question now? Yes. So we can proceed from there. Nasra amesema the particles of the solution pack more closely in the available space, thus reducing the volume. Very correct. Now, Juliet is asking, can one try to do that? Please do it. Ambia ma'am, you are doing an experiment. Aweke chai vizuri na akupe unlimited sugar, spoon tatu. Dissolve. Haitamwagika. Why? It is occupying the spaces within the salt particle. Thank you. I think now we can proceed. Now, I want to enter into another part known as Brownian motion. Brownian motion. Brownian motion. So, tumemalizana na the first part. Now, Brownian motion refers to the random movement of liquids and gas particles. Random movement of liquid and gas particles. That is the definition of Brownian motion. That's the meaning of Brownian motion. Timothy Munga, are you following? Yes. We have three states of matter. But Brownian motion only occurs in two states. Which one? Liquids and gases. Somebody will ask you one day, name the two states of matter in which Brownian motion takes place. So you are supposed to mention liquids and gases. Brownian motion do not take place in solids. What have I said about Brownian motion? Brownian motion is, what do we call this? Brownian motion is the random movement of liquids and gas particles. Hakuna mahali nimemention solid. So wewe ukiweka solid, hiyo ni maneno yako, unachitafutia mwenyewe, so hiyo sisi hatutakubaliana na wewe. Random. Random means it doesn't follow a specific direction. It just moves randomly. It is like you guys over the weekend. Wakati mmefunguliwa kwa shule. Ama wakati mko kwa field. You are randomly moving. Unaenda hivi, unaona hapana, wacha niende hivi, unaenda hivi, unaenda hivi. You find yourself everywhere. That is random movement. Sawa sawa. Now, I will also explain using this scenario. I think it will come out very well. I know most of us nowadays, we don't use firewood to cook. By the way, one of the common questions in the social studies, Hama history in high school, name the main source of fuel in Kenya. The answer during our time was firewood. Is it still the answer? Is it still the answer like nowadays, guys? Nasara, is it still the answer again? Okay, let me ask Juliet. Is firewood still the main source of fuel at home or in Kenya? Wacha nisikie. Ama utaangushwa na mwalimu wako, because mimi tunaona ni kama kidogo kuna venye imechange. That one should no longer be the answer. Yes, Timothy? Timothy, umesema no? What's the main then? I've read your comment. What's the main? Oh, it is. Hey, Nasra is saying no. And then within a minute, amesema tena yes. Anyway, my issue is this. LGB gas, liquefied gas. Okay, sawa. Mimi nimesema, lakini let me explain what I wanted to explain. I've realized hiyo kitu tunataka kuanza sitamalizana nayo. So my question is, when you are at home, especially the house which uses charcoal, firewood, whatever. Okay, say. Moshi ayendangi straight hivi kanaendanga randomly. So that's what I mean by Brownian motion. That's what I mean by Brownian motion. Are you together? Yes. So ama dust particles. It also does not follow as. So it's called Brownian motion. Now, let me say this again. Brownian, in our lab, in our physics lab, we have what we call the smoke cell experiment. In this smoke cell, this is how it looks like. A smoke cell looks this way. Hapa juu ni kuna macho kubwa, macho ya hii macho ni ya hii ni macho ya nani? Hii ni macho ya Jerry. Yes. So alafu hapa kuna light. Hapa kuna ka light kanamulika pale ndani. Then hapa ndani a smoke is deposited. Smoke is being deposited. Don't worry how the smoke is deposited. Tunaweza tafuta mtu mwenye anafuta sigara tumwambia aweke smoke hapa ndani, ama tuwashe karatasi tuweke smoke ndani. Smoke ikiwa ndani, make sure the container is transparent. When you view with your eyes, you will see the smoke particles randomly moving. Randomly. Do not trace a straight path this way ama this way. No, it is moving randomly. Yani inaelekea kila mahali. That is what we mean by Brownian motion. Wengine wana join class wakitoka. I remember my first comment pale juu. I said, thank you for joining this lesson. Stay up to the end. Aya. So now ikiwa hivi, the other one that we can do it is using water. When you have a basin of water, undergoes Brownian motion. But if you try to see with your big eyes, see any motion, you will not see the water moving. But if you can take pollen grains, then you sprinkle on top. Then now you come up and you view it, especially using a hand lens. You will see the particles randomly moving. Why? How can we explain this scenario? Ukiangalia hii, it will be moving randomly. Ukiangalia it's moving randomly. There is a question we gave to students at the end of the term. We asked them, explain why a particle does not trace a straight path when being dropped in the roof of the house. Pale juu ikikuja hivi, haitakuja straight, katakuja kakienda wapi. All this is termed or explained in Brownian motion, which I want us to explain it right now. So in this, let me ask the following questions. Then if you can answer me, answer me. If you cannot, I will still explain. But the best is if you are in a position to answer me, you can answer me. In a smoke cell experiment, why do we use smoke? Give 2 reasons why we use smoke. What is the... Oh, I forgot. Hapa tuko na converging lens. In the lens. What is the role of the lens? What is the role of the lamp? Ama light. What is the role of the light, lens? Why do we use smoke? That's the questions I'm asking. Then, hapa ukitaka, unaweka microscope ama hand lens. What is the role of the hand lens? Mostly we use hand lens because, but you can still use a microscope. If your school has them. Kama ina, use hand lens. Hand lens is somehow simpler, cheaper, easy to use, but performing the same task. But you know, microscope na hiyo ekari ingine kubwa yote inakufikisha mahali unaenda. Aya, what is the role of light, lens, and hand lens? In a converging lens, in hand lens, why do we use a smoke? Those are 4 questions I want us to answer today before we get to the next concepts. I don't know which one are you going to answer. Nasira, I've seen a question you've answered. Hiyo nitakujibu baadaye kidogo. The role of the light is to illuminate the smoke particles so that the smoke particles can be seen. The role of the hand lens is to concentrate light to the smoke particles. That the light that comes from the candle concentrate lights to the, the lens concentrate light from the candle on to the smoke particles. Your light is here, hivi inaenda mahali moja. All the light will be concentrated here. Why do we use smoke particles? We use smoke particles because number one is they are light. Number 2, they are visible. You can see them. These are the 2 reasons why we use smoke particles. Are we together? The role of the hand lens in both cases is to magnify. The hand lens, what do we call this? Microscope is to magnify. Si tuko pamoja hapo, is to magnify. I think we are together there. Sawa. So, unless kama uko na swali, now let me explain a concept here again. How does Brownian motion occurs? And why do we see the smoke particles moving randomly? Because of this. They are being bombarded by the invisible air particles which are in constant random motion. Repeat after me. I'm saying by being bombarded by the invisible air particles which are in constant random motion. That is, if you ask that question when in air. If it is in water, the pollen grains have been placed on the surface of water. Then you feel using a hand lens and you see the pollen grains moving in random directions in Brownian motion. That is, give the reason, because the pollen grains are being bombarded by the invisible water molecules which are in constant random motion. Your statement, it applies. But now, the only thing you are supposed to change is which one is in a constant random motion. Kama ni air ama ni water, that question would be well answered. Understood? Umeelewa? I want to see your participation. Kama umeelewa, type yes. We proceed. Nataka tuingie kitu inaitwa kinetic theory of matter. Kama umeelewa kila kitu yenye nimeeleza, type yes ndio tuingie kinetic theory of matter. Nasra amesema yes. Anybody else? Tuingie kinetic theory of matter. Remember, we are supposed to move very fast. We still have a lot to cover in this topic. Sitaki nirudie topic kesho. Kesho nataka kudiscuss writing of chemical equations from 1 chemistry. Writing of chemical equations. So, can we proceed? Where are the likes of Margaret Njeri Tell me yes, ndio tuendelee. Oh, Margaret, thank you for confirming that. So allow me now to discuss kinetic theory of matter. Kinetic theory ni how is the arrangement of matter. Nifute ubao. Nifute ubao. So kuna solids, kuna liquids na kuna gases. So allow me to draw the particles in solids, in liquids, and in gases. Bernard Mwai, you are saying the main source of fuel in Kenya is charcoal. Really? Mi naona ni fuel, ni LPG gas. Timothy, somebody is challenging you. Anasema ni charcoal. You agree with that person? Una agree naye? Sawa. Anyway, sina wacha nisikomende sana lakini Bernard Mwai. Sawa. Let's say the main source of fuel ni hiyo Kenya umesema. Allow me to look here, everyone. Everybody look here. Your eyes should hapa ni solids. Hapa ndachora ya liquids. Then hapa tuko na ya gas. For liquids, the particles are fixed. I will try to draw them when they are fixed. These are particles for a solid. For liquids, iko hivyo, imejipanga tu vizuri, lakini the problem is they are unaona iko na kashape fulani, lakini sasa zile zingine zimekaa kama nywele ya watu wengine, imekaa tu venye nafikiria. That is for the gas. Are we together? Now, there as these things are concerned, why is the particles of the solid close together firmly fixed? Because the forces of attraction between the particles, ama molecules, is high. What do we call that force? In the molecular forces of attraction, in the molecular forces of attraction, in the molecular forces of attraction, it is very strong in solids, followed by liquids, and lastly in the gas. Now, the reason as to why hapa imeachana kidogo is because the intermolecular force of attraction is weaker in liquids than in solids. It is the weakest in gas. Are you together? So you see here, the particles are together. In this, okay, the distance between one molecule and the other is called the distance between one molecule and the other. Ama one particle and the other is called, hiyo nawangojea mpaka mniambie, hiyo msiponiambia wallahi siendelee na lesson. What is the name of the distance between one molecule and the other one? Kama hii na hii. What do we call this distance? What do we call this distance between this molecule and this? But kumbuka niliwaambianga the other day, in this topic, the word particle can be substituted or used in place of molecule. There is no problem. But my big question tonight, what do we call the distance between two molecules? Nasra amenijibu, Macred Njeri amenijibu, wamesema intermolecular distance. Very correct. Intermolecular distance. So that's how it is. Are you together? That is how it behaves in the molecular distance. Are you together? Yes. So what thing that you need to know ni ile kasi ya form 3. Oh no, not form 3, class 3. Ile ya kuulizwa what is the name of the change of state kuanzia hapa kwenda hivi ama kurudi hivi. Kwenda hivi ama kurudi hivi. Kanaendanga direct huko na kanatoka huko direct kanakuja hapa. So hiyo ni kazi yenye I would not wish to teach you. Sasa nikwambie from here to here ni melting. Na hii ni evaporation. Hii ni condensation na hii ni freezing. Hii inaitwa sublimation na hii from gas direct to solids it is called deposition. Hii inaitwa deposition. This one. Deposition. Hii ingine inaitwa sublimation. Sublimation. Si hapo tuko pamoja. So the rest of the things si vitu ngumu ngumu. At the end of this topic kuna maswali ndaulizia. I hope you will be there to answer them or to see how they are being answered. So I want to get to something else. So unajua nimemalizana na kinetic theory of matter, Brownian motion, introduction part of the topic. Now, I want to get to what we call diffusion. Are you ready to let me start diffusion? Can we start diffusion ama kuna mtu ako na swali? Kama uko na swali, you can... Kama uko na swali, unaweza niuliza. Lakini kama hauna swali hii, and you want me to proceed to diffusion, please niambie yes. Just the word yes there would mean I proceed. Sawa sawa? Is it our last part really? Diffusion, yeah. Diffusion is among our last parts ya the topic. Then tuingie maswali 2-3. I release you kwa and take 4 o'clock tea. Si mnajua kuna 4 o'clock tea? Yes. Diffusion. So let me clean the board. Next time I will employ one of you, one of the students, to be cleaning the board for me. To be cleaning the board for me. Yes. Margaret amenipea go ahead, akaniambia hiyo lesson twanga vizuri. Pika hiyo lesson vizuri, sawa sawa, nataka niingie diffusion. I don't teach biology, but there are 3 things. Okay, anyway, I've been teaching biology. Hata 2019 nilifunza form 4. Kuna shule nilienda nikafunza 3 sciences na maths. You can imagine. Naingia class nafunza physics. Natoka nafunza maths, nafunza chemistry, na malizia na biology. Hao watoto walikuwa wanaboeka na mimi, lakini sasa ningefanyaje? Na ni mimi ndio nilikuwa. So in biology, we used to teach or we used to be taught about the following movements that happens. We have diffusion, we have osmosis, and we have active transport. Kidogo before to answer diffusion, can someone type for me what is active transport? Osmosis. Na mwingine atuambie what is. Today I want to teach diffusion. By the way, swali ya biology ukiniletea nitakujibu tu. Sasa unajua si ngumu. By the way, biology si ngumu. Ni wanafunzi wanafanya ikuwe ngumu. Now, I'm waiting as I'm talking actually, nikiwapikia hii story kidogo kidogo. I'm waiting to see someone typing active transport, atupatie definition ya active transport. Mwingine atupatie definition ya osmosis. Then lastly now, mwingine atupatie definition ya diffusion. That is where we are heading. Yeah, inafaa to answer kwa kinetic theory of matter. And we have how many minutes? We have 19 minutes to do so, to discuss diffusion. Kesho ndakuwa na discuss chemistry na ndakuwa na ongea kuhusu writing of chemical formulas. Sawa sawa? Yes. So, is there anyone typing? I'm waiting for you. Ndio mniambie venye iko. In the meantime, this is what we are learning. Diffusion. Diffusion. Nasra, ulimaliza kufanya mtihani nilikupea? I want to mark them. Weka kwa pasha unitumie nikumakie. Nimepata definition ya osmosis from Nasra. I'm waiting for active transport from somebody else. Hakuna mtu mwingine anataka kuandika? Nasra, thank you for that comment. Very nice one. Aya, so nataka tuingie sasa. Nasra is saying, osmosis is the movement of water molecules from a region of low concentration to a region of high concentration. So let's start by defining Nasra, the exam. Oh, si wewe ndio nilikupa exam, sorry. Nimekuconfuse na sister yako mwingine. Nimerealize. Diffusion refers to the process by which particles spread from a region of high concentration to a region of low concentration. Particles moving from a region of high concentration to a region of low concentration. It takes place in liquids and gases. It also takes place in solids, but in a very rare way. Pole tu. Aya, anyway. So let me say this. In fact, it's good because kuna mtu ametype na akatuambia what is osmosis. Now, because you have given us the meaning of the word osmosis, will I be correct, boys and girls, will I be correct to say osmosis is a special type of diffusion? Will I be correct? Aya, Margaret Njeri amesema active transport is the movement of molecules across a cell membrane against a concentration gradient. Thank you. That is exactly what is active transport. But for today, we will not discuss osmosis or active transport. We are going to discuss diffusion. Are we together? So in short, nimekuna swali nimeuliza na Nasra amejibu that osmosis is a special type of diffusion. Why? Because it involves movement of water molecules from a region of high concentration to a region of low concentration. Talk of hypotonic solutions. Yeah, aina shida. Now, let's talk about diffusion. I think nimewambia what diffusion is. The movement of particles from a region of high concentration to a region of low concentration. I want to demonstrate diffusion in liquids, and I hope you are ready for the same. Diffusion in liquids, then we look at the diffusion in gases. Then, though not in the syllabus, someone to remind me to also talk about diffusion in solids. Now look at this. If we have water here, then we use a tube. Tube imekaa hivyo. Weke tu pole pole. Which liquid can we use? Copper 2 sulfate. Let's use copper 2 sulfate. What is the color of copper 2 sulfate? Muniandikia hapo kwa comment section. What is the color of copper 2 sulfate? What is the color of copper 2 sulfate? So hiyo copper 2 sulfate tumeitumia kwa tube kaingie. Mbona tusiweke direct? Because ukiweka direct, the whole water will change to blue very fast. The whole water will change to blue very fast. Lakini sisi tunataka tuone ikispread. Nauliza what is the color of copper 2 sulfate, amtaki kuniambia, ndio? Aya, now unaweka hapo copper 2 sulfate, inaikaa hapa chini. Hiyo copper 2 sulfate, hiyo kale yenye sitaki kusema na ngojea mniambie, itakaa hapa kwanza. Then unaenda unapika shughuli zako. Unaenda unakunywa chai ama soda. After some time, like 1 hour, the whole of the solution, because the whole of the solution will be blue. Why? Copper 2 sulfate is blue in color. The whole of the solution is going to be blue, and therefore it will have spread. That is diffusion in liquids. I have a question. What if we use warm water? What will be the difference, if any, we use warm water? What will be the difference, if any, if we use warm water? if we use warm water? Margaret, Jerry, any exam for me, sir? Where are you, Margaret? Where is your location? I can organize, I deliver for you an exam for all the subjects. Where are you? Okay, just tell me where you are. I will organize for you. I have many exams. In fact, I'm a dealer of exams. Revision papers, use of it, so mimi ndio na deal naso. Now, what if we use warm water? What will be the difference? I will explain that. If we use warm water, the process of division will be very fast or faster. Why? Why is division faster? When the temperatures are high. When the temperatures are high, division is faster because the kinetic energy is also high. Are you getting me? And that is division in liquids. It is faster when the temperatures are high. Are we together? Are we together? Yes. Margaret Jerry. Copper 2 sulfate can never be purple. Sisi kwa nimeona umechange. Purple is the color of potassium permanganate. Yes, Nasra is saying the movement of the particles is faster due to increased energy. Be very specific. Which energy, Nasra? It's kinetic energy. So that is division in liquids. Division in gases is demonstrated in various ways, including Margaret, kama huko Kiambu, then I will send you tomorrow morning. WhatsApp this number, Margaret, 0796 26 24 71. WhatsApp that number. Kiambu tu, kuna hizi makari za Kiambu zinaitwa kakose, ama ni makari gani zinaitwa Kiambu? Ni gani? Likabu. Ki? Likabu. Oh, Likabu ndio zinaendanga Kiambu. So I will deliver you that exam. Just WhatsApp me in that number, or you tell your mom or dad to WhatsApp me in that number. You will get the exam tomorrow. Ufanye ukimaliza unirudishie chemistry, physics, pia unirudishie ya those that I can mark, pia unirudishie maths, ya history. The only one that siwezi nikamark the languages. Kisungu nayo sitakangi kukunisumbua, lakini history sote I will just sit down. Swali ya siari ikinisumbua napigia Mr. Cheke. Hii swali ananipea answer haraka haraka. Anyway, let me look at division in gases. Sasa, I will use this example to describe diffusion in gases. One, sometimes the teacher is outside your class and you already know which teacher is that. Why? Umesikia harufu ya marashi yake. Unfortunately, mimi situmiangi kwa chachi ndo nitumia. Ndio. Haya, check pale. Welcome back. Sorry, I was just changing the camera, the battery of the camera, lakini usijali. So unaona hata iliandika ikasema change the battery, ndio? But I'm back. Can you hear me now? Those who are in, can you hear me? Just comment yes. Can you hear me? We proceed. I want to talk about diffusion in gases. So I'm saying this. Ukiwa pale ndani ya class unasoma CRE ukilala, then unasikia tu nimesikia marashi fulani. Hiyo ni Mr. So and so ama Madam so and so. Why? Mbona umesikia marashi yake na hajakuja mahali huko? Yeah, because hiyo marashi iko highly concentrated mahali yako. Lakini mahali we huko iko kidogo, so ilikuja mahali huko ili diffuse. That is it. Mimi nikiwa high school Our kitchen ilikuwa upande ya juu hivi, so hiyo upepo ilikuwa inaleta kwanza. My favorite food is githeri. Sasa ilikuwa inaleta harufu ya githeri yenye wamekatia kitunguu, ile kitunguu ya shamba, ile ya matawi. Wachana na hii kitunguu ya bulbs, ile ya matawi, na wameweka chumvi. Yani nasikia hiyo harufu hata hiyo physics sisi kwa naishika tena, ilikuwa ina diffuse. So diffusion involves gas particles moving from one region to the other one. That's why marashi ilinunuliwa because inaweza diffuse. Kama marashi ingekuwa ikidifuse, then ingekuwa inafanya kazi yake vizuri. Lakini let me use this example that I used when I was teaching my class. Nani, are we still together? Timo, are we still together? Yes. Okay. Kuna mtu ananiambia I did not finish. Kidogo tu, I'm just writing something. Look at this. There's something I want to show you. If you have two gas jars, ikuwe na bromine gas, ikuwe na air. Kumbuka air is colorless, bromine gas is brown fumes. So if you bring it together this way, the bromine gas will be diffusing this way and the air will be diffusing this way. At the end of the day, the whole container will be brown. Why? Bromine itakuwa diffuse all through. Even the air diffuse, but remember air is colorless, so that's why you cannot see it. The other example which I will use right now is this. Hapa, Timo, can you see what I'm writing on the board? Hapa tuko na cotton wool soaked in hydrochloric acid. Wale mko form 1, hydrochloric acid ni HCl. Sitakuwa naandika ati hydrochloric in HCl. Na hapa tuko na a cotton wool soaked in ammonia. Timo, ammonia is written as NH3. You should know as early as now, NH3 is ammonia. So ammonia fumes, ama gas, will be diffusing this way. HCl gas will be moving this way. They will meet somewhere in the middle. What is the name of the compound? That's okay, to go physics like in the chemistry. What is the name of the compound formed when HCl, ama hydrochloric acid, meet with ammonia? Ebu mniambia haraka ni gani? What is the name of the compound that will be formed here in the middle? Because ammonia fumes, HCl fumes will meet, they form a compound. And that compound is visible. We will see it. We can see it. Its color is white. What do we call that? Niandikia haraka. Remember, we only have less than 10 minutes. Okay, let's say 10 minutes. What do we call it? So as you are planning to give me the name of the compound formed here, I know you are on your own typing, so let me proceed with the lesson. So a white substance will be formed here. It is the white substance that you have refused to tell me its name. A white substance. To my Nasra, it's called ammonium chloride. Very well, it is called ammonium chloride. Ammonium chloride. So look here. Look at this distance. Now, one distance. This is longer than this. What does that indicate or show? It shows that ammonia traveled through a longer distance than hydrochloric acid. So which gas diffuses faster. Umeambia mtu kuja tukutane, then ukienda mkutane, mkakutana karibu na mahali ametoka, meaning you moved faster than that person. So ammonia diffuses faster than hydrochloric acid. Why? Why did mbona? Ni swali tunauliza, mbona ilienda mbio mbio? Why did it move faster? Yes. So it moved faster because ammonia is having a less mass, molecular mass. Yes. Molecular mass yake iko kidogo kuliko ya HCl. So in physics, mass and density are directly proportional if we maintain the volume constant. So this one is less dense than this. So this one is slower, this is faster. So this one will travel a longer distance than this. What will be the explanation and observation when the temperatures are high? The formation of ammonium chloride would take place faster or very fast. Thank you for that. So that is diffusion in gases. Now, write this. Diffusion in gases is faster than in liquids because it's a statement, and everybody must write. Diffusion in gases is faster than in liquids because, number one, because number one, they have low density. Because number one, gases have low density. Number two, because they have high kinetic energy. Because gases have high kinetic energy. Number three, I'm giving reasons why gases diffuse faster than liquids. Then because they have weak cohesive forces of attraction. Are you writing this? Mandega is sosote. Yes. And it's a common question that you will be, mostly be asked, why gases have a faster rate of diffusion than liquids. Are you together? Yes. State two factors affecting the rate of diffusion. State two factors affecting the rate of diffusion. State two factors affecting the rate of diffusion in liquids. Sorry, in gases. Two factors affecting the rate of diffusion in gases. Name and explain. Let me change that question to be name and explain the factors that affect the rate of diffusion in gases. Iyo mkijibu, we end the lesson there for today. If you can answer me that, we will end the lesson there for today. We will meet tomorrow for writing of chemical equations. Timothy? Timo? Timo.
Temperature and density.
Temperature and density. Timo has said temperature and density. I want to hear those guys from YouTube. What are you saying? Nasra anasema temperature and density. Well, anybody else who is still typing? Timothy, from tomorrow you will be joining using YouTube. Are we together, Timo? So, yes. Yeah, so I want to sign out. See you tomorrow at from 3 p.m. to 4 p.m. For chemistry. We shall be learning how to write chemical equations, chemical formulas, all those that disturbs people from the Form 2. See you then, and receive a lot of gratitude and love from Ambassador Foundation. Before I walk away, if you have any question, my number is there on the board. Nimeandika hapo kwa chat 0796 26 24 71. If you are in need of any exam and you are within Nairobi region, Kiambu, Nakuru, I will send you the exams, especially for chemistry, physics. So, okay, you're gonna the whole subjects. You do it, then you send it back to me. I think that's what I will be doing. We itisha mtihani nikutumie, ufanye ulete ni mark nikurudishie mtihani uone. Are you together? Yes. So have a nice day. We can sign out. Hii kitu nimefurahia.